I hope you got the idea that solids are the component that causes the issue in oil-water separation. Now, it's oil-water separation design, but it's not so much the oil that causes the problem with meeting compliance. It's the solids. And if we deal with solids, we're going to have success in our separation. So at Mercer, we've kind of developed a little formula, and we live by it as we tweak our designs and do things. It's oil plus solids plus time, and the question is, what does that equal? And we'll go on and we'll show you what that equals. It always equals sludge. Oil in the presence of solids over a certain amount of time always comes up with sludge. And what we find out is that Phil talked about these technologies. Some of the pictures are shown. These technologies all work, and every one that was shown has a certain amount of high efficiency to them. The problem is they only work for short periods of time. So as you're considering coalescers, as you're considering what to do, one thing we want you to be aware of is that a coalescer needs to process solids out of the pack. If it simply filters solids, you have a problem. If it can process solids down and out of the pack, you're in good shape. So that's part of the key as you're looking around to figure out how do we extend time between maintenance? How do we keep our unit within the limits of our effluent permits? The other area that's often missed, and this is key, is how do you keep oils and solids apart? Since they both create sludge over time, if we can keep them separate, I can show you on the next slide what we do a little different than some of these other ones. We build a versatile pack. On the left-hand side is a modern-day flat plate design pack that Phil was talking about. We had, early on, we had the ability to talk to several people in the electric utility industry about what they liked on their separators, what they didn't like. They gave us the feedback, and almost invariably, they said, look, it's the coalescer. They foul quickly. They don't process solids, and we can't keep in compliance over this. So when we designed our system a little more than 20 years ago, we found that this is what we keyed on. We keyed on long runs between maintenance. And we found that if we dealt with solids and also kept the criteria for, down in that 60 micron range, we're going to be in good shape for long periods of time for our clients. So the first thing you're going to note is that this coalescer shown here, this is an entry area view. We're a little higher so you can see some depth. Basically, this is an entry area view. So the flow is coming in this area right here. You'll notice flat plate design. It's a flat plate that goes all the way through the coalescer pack. Critical. And we're finding that this time-honored flat plate design is something we've come full circle on. This was the original design concept. And the flat plate design at a 55-degree steep angle, that's where we are here. If you're in a 55 or 60-degree angle, you have a much better shot of solids falling down and out of the plate pack system. But the fact is that if we're steep and we have a flat plate design, there are no nooks and crannies. If you look at the other designs we looked at today, lots of nooks and crannies, lots of places for the solids to lodge. Once solids lodge in a plate, they kind of grow off of each other and the fouling goes much more quickly. A cross-flow design. In today's marketplace, all the real designers go with a cross-flow design. Phil mentioned the upflows and the downflows. They're both countercurrent, meaning one of the components, like solids, has to fight against the flow of water. When it does that, it tends to ramp up and plug. So if you move this to a countercurrent design, like we have here, water's flowing here, and water flows through the separator all the way to the back end. Water, oil, and solids all are heading in the same general direction. With that, you can keep the plate gaps here much tighter without the same fouling. Moving on to our next area, I think is important, is the herringbone design. There's several manufacturers in the industry that design a herringbone design. What do we mean by that? We mean we take the plates and we break them up into something like you'd see on a herringbone jacket, where the plate widths are short. Instead of a plate width being up here and having to travel solids all the way down to the bottom out of the pack, 6, 7, 8 foot on a large unit. By breaking up the plate width, now we only have to travel this far. On a Mercer design, that's 24 inches. So as you're looking at it throughout industry and you're comparing and contrasting and considering designs, look for a plate pack system with short plate widths. The short plate widths are very important. It also gives you a tighter rise to run ratio, and that's important for solids. So instead of solids up here having to fall way down a plate, ramping up and plugging, now it only has to fall 24 inches. That's important. The other thing to look for that we've incorporated is to be able to process solids. Will your coalescer, the one that you have or the one that you're looking to get, does it process solids? And we've incorporated chimney zones. So in between our plate widths, our herringbone design, we've incorporated dedicated zero velocity areas. And what I mean by dedicated is we have one dedicated for solids, one for oils, solids, oils, and solids. Remember, oils and solids over time create sludge. So what we want to do is separate them. So in this case, solids will fall down plates here, and they will hit a dedicated chimney zone. This, as soon as a solid falls out, can take all the time it wants to fall out. Kind of a neat concept. And by doing this, by being able to process solids down and out, you're going to extend the time between cleanings, and you're actually going to stay in compliance much longer. On our next slide, we'll see that a different view. Here's the coalescer. It's a nice 4-inch deep. And here you can see this chimney zone goes the full width, the full flow direction of the coalescer. The plates are in place here. Solids fall out, drop out. This particular one, by the way, is a 3 foot by about 4 foot. This will process about 100 gallons per minute. Now on this side, this is the flow through this set of plates and through this set of plates. The solids will fall down in both directions, hit the chimney zone. So this is a good shot of one part of the chimney zone here. The baffles here and here keep the flow out of this area. So as soon as solids fall out, they'll take their time and can be processed out of the pack. On the next slide, you'll see the same thing. It's a herringbone design. In fact, we saw the slide earlier. Not only is this manufacturer got a herringbone design, which is better, it's cross-flow. That's better too. Part of the issues here, again, are the nooks and crannies that they have here. The nooks and crannies create all kinds of problems. But let's say the solids do make their way down here and down here. They dead end, especially on the larger units, anything 500 GPM and above. They're stacking these things side to side and top to bottom. And when they stack this bundle and this bundle together in their herringbone design, there's a dead end here. So if solids do make it down here, the solids grow back. The bigger the unit, the bigger the problem with solids. Okay, and as we go on, we'll see the difference between a herringbone design with and without an area for solids. Here, two bundles together, and what's happening is the weight of the solids that have built up eventually overtake and collapse the packs. The packs are not inexpensive, and what will happen is as the solids build up, they sit, and finally you'll see what's happening here. With a big chimney zone like we have here, maybe we should call it a beefy zone instead of a chimney zone, because it's just big. It's almost impossible to foul. I've been looking at these things in the field for many, many years, and I have not seen one fouled yet. That's how big the chimney is on here, and that's important, because if you can process solids, you're in good shape. The next thing we want to talk about, and this is often overlooked, is the ease of cleaning. If you find a coalescer that's easy to clean, you're in good shape. And one thing you can do to kind of feel out, will it be easy to clean? Will the solids process out? Imagine having a nice, clean, brand new coalescer in front of you. Imagine the one you're either using or the one you're planning to buy. And imagine having a big two-fisted handful of like a coarse sand. Throw that into the coalescer, in the entry area, or throw it in on the top. What's going to happen to that sand? If 20 or 25% of that sand doesn't find its way falling out of the coalescer, that's a problem. So as you're comparing, contrasting, considering various designs for your next application or for upgrading what you have, I'll tell you, that's a good one. If you were to put sand in there, are the sand particles going to find their way out? If they are, you got a good design. If they're not, you have a problem. Ease of cleaning. If you're able to clean the pack all the way through, you've got a good design. If you can't, I think you're in a little trouble. Here's a picture of a guy in the entry area of the coalescer. The maintenance guy is cleaning up, and the next slide shows what a cross-flow, flat plate, short width design with chimney zones does. He is a 5-foot distance here, and there's still velocity coming through there. We can clean from this part of the separator, from this part. We can clean from this part of the coalescer. We can clean from the back of the coalescer. All these areas to clean. Not only that, but as the water comes in, it flushes down, hits the chimney zone, and out. Kind of an interesting thing. Now, if you can't clean your coalescer completely, what happens is the inside doesn't get cleaned out. You saw some photos from before. So the moment you put it back in for work, you've already have a reduced performance, and there's immediate reduction in performance and the ability to pull out oils. Not only that, but you're handicapping yourself on how long you can extend your cleaning. All right, moving on, we build the stainless steel packs. A nice stainless steel pack, they have a smooth, flat, hard plate that stays good for years. That's important for moving and processing solids, as opposed to some plates that'll sag or corrode or things like that. I love the stainless steel feature. We use these in the oil and gas, the electric utility, the petrochemical. These are the things that are going to last for years and years, not needing the replacement. And finally, the last thing I want to talk about is versatility. You got to pick a coalescer system that's going to be versatile. Here's our standard design. We ship these out with every other plate in place. It is a 1-inch gap, and it's an adjustable plate gap system in which, if we want a less maintenance routine, if you can't put the maintenance into it that's required, if you need to bump that out, we build the coalescer a little bigger and maybe go in with the 2-inch plate gap instead of a standard 1-inch. If you're at a 2-inch plate gap and you decide you need tighter plates in the field, you can simply slide the plates in, done. Back to 60 micron removal, which is great. Now, we do know that there are times where the wastewater characteristics will change, flow rates are going to increase, oil content's higher, or if effluent regulations change, if you're down to 5 ppm, and believe me, it's coming. We're shipping things overseas where the requirement's 5 parts per million now. They realize that the environmental thing's here to stay, and they're taking care of that. So in this case, we're able to get down to a 1/2 inch, which is a 5/16 right angle gap, and bring it down into that 45 micron removal. That's about as tight as you get in the industry. Also, the plates are completely removable, so if there's any real burdensome, sticky, stubborn solids, you can take the plate out and clean it right up. On the next slide, you'll see a typical maybe 600 GPM coalescer. Here's one with their standard plates in place. Every other plate. With every other plate in place, we've got a 1-inch gap, real high efficiency. This is an all stainless steel pack. This one's used in about 180 Fahrenheit. Years later, still looking really good. With every plate in place, 45 micron removal, we're about in the highest efficiency available in the industry. Now, that's with a cross-flow design, chimney zones, flat plate. These things can go a quarter, 6 months without fouling. Real good. And the next slide shows a client who said, look, we can't put the time into maintenance. We only want to maintain this stuff every couple of years. So what we did was we grew the coalescer a little bit and put in every 4th plate. Actually, it was actually more than that, and we ended up getting a 4-inch plate gap out of this thing. So what they got was they got an oversized coalescer so that we could still give them the efficiency they needed to get down into low ppm range. We were able to give them low maintenance, so every couple of years they could pull this thing out and was still operating. And there's room for versatility. So in the future, if anything changed, they're in good shape. I know my time's up. I would like to go over one more slide. It's kind of a next generation innovation. And this is a staggered plate design we've been working on. And as solids are in the wastewater and they've got to get down to these 5 part per million things, what we do is we stagger the plates. So the front end of the plate near the entry area, we may have a couple of inches, couple-inch gap. This is to take care of a lot of the solids so that as we go into the tighter plate gaps, here getting 60 micron, we've taken out a bunch of the solids that the upfront empty container won't take care of. In this area then, we can run longer because this took out some of the solids that would have plugged this area. And we can actually, on our bigger coalescers, put the tightest plate gaps over here. By doing that, we can really squeeze out the most from a coalescer system. As the oil and grease limits get stricter, this is going to become more and more interesting. We built a few of these and have very good, we've had very good performance out of that. And the last slide, just as a quick overview, we build above ground, below ground rectangular, we retrofit rentals. We do an awful lot of custom design, and interested to hopefully see some applications that you may have.